Hi, my name is Mark Dittmer. This is American Indian Public High School geometry, and this is a mini lesson on how to use properties and medians, properties of the medians of a triangle, and how to use the properties of the altitudes of a triangle. So the key new words there are medians and altitudes, and they come from this chart which we copied in class before, but these are all different special segments of a triangle, and there's three of each in a triangle, right? Because you can do a perpendicular bisector to each side, and when you do three perpendicular bisectors, they meet at the circumcenter. You can do an angle bisector to each angle, and take three angle bisectors, they meet at the incenter. And you can do three medians from each corner to the opposite midpoint, and they meet at the centroid. And you can do three altitudes, which is the most complicated of the three, and they meet at the orthocenter. Okay, so and I'll show you what I'm talking about with them because these are the new ones. So the median, just to be clear, it's endpoints, segment whose endpoints are the vertex, that's the corner of a triangle, and the midpoint of the opposite side. Remember, you can pause me if I'm going too fast. I'm going to show you what that looks like. Here's a triangle. So I'm going to draw a segment. Actually, I'm going to draw a midpoint. Midpoint of this line, midpoint of this line, midpoint of this line. So this program, I just click there and it finds the midpoint automatically. Remember, it's exact middle of that line. And then to draw a segment, I can go from the corner to the midpoint. That's a median. Corner to the midpoint. That's another median. Corner to the midpoint. That's another median. Okay. So where the three medians meet, that's the centroid. And so the rest of this lesson will be about the median and the how to find the centroid, or some special properties of the centroid. So the first problem that I'm going to look at asks us if in this drawing PT is 5, so this segment right here is 5 in length, right? The length of PT, if I say PT equals 5, since I didn't make a bar above this, that just means I'm talking about how long it is. How long is it? It's 5. So then find RT and RP. RT and RP. Well, you do that using a certain rule, which basically says that the centroid it breaks up every median into thirds. Breaks up every median into thirds. Let me show you what I'm talking about. Okay, so if basically at this median, every median is divided into thirds, and basically, so how many thirds are there in a median? Well, there's 3 of them, right? So 3 thirds makes 1. So every median is divided into 3 parts, with 2 of them on one side of the median and 1 of them on the other. So this is 2 thirds, and this is 1 third. Now, they're not all equal. Like, obviously, this median is longer, but 2 thirds of it is on this side, and 1 third of it is on that side. So, and what do you notice? That 2 thirds is bigger than 1 third. 2 thirds equals 1 third times 2. Okay, which basically what I'm trying to say is, what algebra lets me do is say that if, instead of actually calling it 1 third, I can call it 1 third x and 2 thirds x. So if the distance of the median is x, then this is 1 third of it, and this is 2 thirds of it. And Here we've got a different x, but this is 1/3 of this x, and this is 2/3 of this x. Okay, knowing that, I can go back to this example, and if that's 5, well, that's 5 is 1/3 times 1/3 of, because 1/3 times and 1/3 of are the same thing, 1/3 of RT. So 5 equals 1/3 RT. So then I'm going to multiply by 3 on both sides, and I'm going to get 15 equals RT. So RT is 15, and if RT is 15, if this is all 15, and the little PT is 5, that means PR, the other part they asked for, must be 15 minus 5, or 10. So that's our first example. Our second example says, find the coordinates of the centroid. All right, this is a little harder, but we can do it. So they give us the 3 points on the triangle, and then they tell us. Wait, hold the phone. Hang on. They tell us that this is 7, 10, and this is 5, 2. So what I need to know is the slope of that line, because then I can find, well, actually I can find the midpoint anyway, right? The centroid goes to the midpoint. So, and what's going to be easier is to use the two medians I already have. So it's 3 commas, this line here goes from from 3, 6 to 7, 10. So what's right in between 3, 6 and 7, 10? Well, what's right in between 3 and 7? Well, that's 5. And what's right in between 6 and 10? Well, that's 8. So that point there, point N, has to be 5, 8. And over here, using the same method, but now I'm using these 2 points. This point here must be 4, 4. Okay, so now I know all my points that make those. I've got 4 points making 2 lines, right? Those 2 red lines. And I want to find where they intersect. So I need to find what's the equation of those lines. So I'm going to use point slope form to do that. So first I need to find the slope of those lines. So the line NK goes from 5, 8 to 5, 2. It has an undefined slope. So that first line is a straight vertical line from N down here is a straight vertical line. And what doesn't change? That X always equals 5. So right, that's what that line is. Now the other line, this yellow line now, I'm making it yellow, goes from 4, 4 to 7, 10. So if it goes from 4, 4 to 7, 10, that means it goes over 3 and up 6. So its slope is up 6 over 3. So its slope is 2. And since its slope is 2, I'm going to say, all right, y equals mx plus b. And so y equals 2x plus b. And then I'm going to plug in a point on the line. And I'm pretty sure 4, 4 was a point on the line. No, it was, yep, 4, 4. It starts at 4, 4. So I can plug in 4 equals 2 times 4 plus b. So 4 equals 8 plus b. So b equals, I subtract 8 from both sides, b equals -4. And so the equation for that line is y equals 2x, we know the slope is 2, minus 4. So now I want to find where y equals 2x minus 4 crosses x equals 4. Right? Because that was the other line was, oh, sorry, x equals 5. So where do these two lines cross? So what I'm going to do is I'm going to substitute x equals 5 into this equation. So I'll go y equals 2 times 5 minus 4. Y equals 10 minus 4, or 6. Now, if y is 6 and x is 5, then I know that this point must be 5, 6. And that's the point of the centroid. All right, well, I hope that helps. I hope this was recording, because I don't see it. I don't see the button. All right, but I'm going to stop talking now. I'm signing off. Hope you enjoyed this geometry video. If you have questions, ask them in class tomorrow. You know, there is one more thing I can show you, and that's what an altitude is. So if you're looking for more notes to take, I'll take them here. So here we have, looks like, oops. Wow. All right, that's what we want. Now I want to extend this line, so I'm going to choose. I want to choose an object. So basically just extend that line, and I'm going to do the same thing with here. Extend this line, and here, extend, oops, that's not what I wanted to do. Okay, so now on altitude, and let's, you know what, I'm going to get rid of some lines. Let's get rid of this centroid. And you can get rid of the midpoints too, because an altitude doesn't use the midpoints. An altitude comes from the corner, but it's a perpendicular line. So like, you know, an angle bisector comes from the corner, a median comes from the corner, but an altitude comes from the corner, but it's perpendicular to this line. So I want to actually, let's extend this line. So I'm going to draw a perpendicular line from this point to this line. That didn't work. Perpendicular line, select point, select perpendicular line. Select. Let's try with another point. From this point, no. From this point, holy moly. Okay, I want to get rid of something. Get rid of this thing. What the heck is that even doing there? I'll get rid of that thing too. I want this line to be extended. All right, now let's try this again. Perpendicular line from this point to this line. There we go. That's an altitude. That's 90 degrees right there. Go again. Perpendicular from here to this line. That's an altitude. Those are so far the altitudes look like they're outside the triangle, but they're not always. Perpendicular line from this one to here. Whoops, why did I lose it?